All right, we're looking at the 11C practice test. The first question here says, resting pulse rate is an important measure of the fitness of a person's cardiovascular system, with a lower rate indicative of greater fitness. The mean pulse rate for all adult males is approximately 72 beats per minute. A random sample of 25 male students currently enrolled in the Faculty of Agriculture was selected, and the mean resting pulse rate was found to be 80 beats per minute with a standard deviation of 20 beats per minute. The experimenter wishes to test if the students are less fit on average than the general population. The null hypothesis here would be that the mean is 72 because that is what it's always been from the population. And in the sample, since they found the heart rate to be 80, that's more than 72. So your alternative hypothesis would be that the mean is greater than 72. And make sure you're using mu, not x bar, for your hypotheses. So the answer for number 1 is E. For question 2, a type 2 error in this situation would be what? And so a type 2 error is when you fail to reject the null hypothesis when the alternate hypothesis is true. So failing to reject the null hypothesis would be to conclude that the students have the same fitness, that their heart rate is 72 beats per minute, when in fact it's not. And it's not in this situation would be that their heart rate is greater than 72, so they are less fit than average. So B is the answer for number 2. Number 3, a significance test gives a p-value of 0.04. This is about whether you reject or you can fail to reject at a certain alpha level. In order to reject, you need to have your p-value be lower than your given alpha level. So we can't reject at the 1% because 0.04 is not less than 0.01, but it is less than 0.05, so the answer for 3 is B. C and D aren't applicable to what we talk about with significance tests. For number 4, it says the significance test was performed to test the null hypothesis H naught is mu equals 2 versus the alternative hypothesis mu does not equal 2. The test statistic is 1.4. The p-value for this test is approximately what? So because this is a two-sided alternative test, because it's not equal instead of just greater than or less than, your test statistic of z being 1.4, you need to place that on a normal curve and show 1.4 and negative 1.4. And the p-value for this problem would be anything that's greater than 1.4 or less than negative 1.4. So the way you find those two tails, the sum of them, is you're going to do 1 minus normal CDF of the lower bound negative 1.4, comma upper bound positive 1.4. And when you do that, that'll give you 0.1615, which is A. For question 5, it says an appropriate 95% confidence interval for mu has been calculated as negative 0.73 to 1.92 based on n equals 15 observations from a population with a normal distribution. The hypotheses of interest are the null being mu equals 0 versus the alternative being mu not equal to 0. Based on this confidence interval, if we have a 95% confidence interval, that means our alpha level is 0.05 because it's just 1 minus the confidence interval. And so we found that the null hypothesis 0 is within our range from our sample test. And if the null is within the range that you found, that means you are not going to reject the null hypothesis because it's probably true since it's within your confidence interval. And so you are not rejecting it at the alpha equals 0.05 level of significance. Question 6, the most important condition for sound conclusions from statistical inference is usually that the data can be thought of as a random sample from the population of interest. If you don't have a random sample, you have a biased sample in some sense, and your data is not going to be reliable. For question 7, it deals with increasing power on a significance test. The answer is D. You can increase the significance level alpha. Um, the other answers wouldn't work for, a variety of reasons. Generally, you want to increase your sample size. You want to decrease the standard deviation. Performing the test many times wouldn't necessarily increase the power. Um, Using a two-tailed test would generally give you a larger p-value, which would make it a lot harder to reject the null hypothesis. For question 8, it says a medical researcher is working on a new treatment for a certain type of cancer. After diagnosis, the average survival time on the standard treatment is 2 years. In an early trial, she tries the new treatment on 3 subjects who have an average survival time of 4 years after diagnosis. Although the survival time has doubled, the results are not statistically significant even at the 0.10 significance level. The explanation is that what? And the thing that stands out or should stand out to you from this trial is that the researcher, tested their method on only 3 people. 3 is an incredibly low sample size, and you can't really draw any solid conclusions from a sample that's that small. So the answer is B on number 8. Moving on to the free response section. Question 9 says, it is believed that the average amount of money spent per U.S. household per week on food is about $98 with a standard deviation of $10. A random sample of 100 households in a certain affluent community yields a mean weekly food budget of $100. We want to test the hypothesis that the mean weekly food budget for all households in this community is higher than the national average. Perform a significance test at the alpha equals 0.05 significance level following the inference toolbox. So the first step are hypotheses. The null hypothesis is that the mean is 98 versus the alternative hypothesis being the mean greater than 98, where mean is the average weekly spending in a U.S. household on food. Our conditions, normality, SRS, and independence. The normality condition is satisfied by the central limit theorem since our sample in this problem was 100 households and that number is greater than 30, so you can assume normality. The SRS, it's not necessarily an SRS, but it is a random sample, so we're not 100% confident in our result, in our answer necessarily. So we might have a little bit of caution, we might be a little bit reserved with our conclusions, but it is good still that it is a random sample. For independence, again, the condition for this, you want to check that, see that the population is at least 10 times the sample size. And if our sample is 100, 10 times that is 1,000. And there's certainly at least 1,000 households in the US. So we can assume that the 100 households in this test are independent of each other. From this information, we're going to do a one sample z-test because we know the standard deviation. Step 3 are calculations. To find the z-score, we're going to do x bar minus mu divided by sigma over square root of n. You plug in the numbers that they're given and you get the value of 2. So to find your p-value, you're going to do the normal CDF, 2 as your lower bound, and a large number, 10,000, as your upper bound, because our alternative hypothesis is greater than 98, so we're doing the upper end of the graph. We get a p-value of 0.0228 from the calculator. And so therefore our conclusion is at the alpha equals 0.05 level, there is significant evidence to reject the null hypothesis and conclude that the average US household spends more than $98 weekly on food. And again, we are concluding this because our p-value is lower than the alpha level. Part B says, describe a type 1 error in the context of this problem. What is the probability of making a type 1 error? So a type 1 error in this problem would be when you assume that the US households spend more than $98 weekly on food when they don't. And the probability of that is your alpha level, which is just 0.05. For part C, we need to describe a type 2 error in the context of the problem and then give 2 ways to reduce the probability of a type 2 error. So a type 2 error here would be assuming that the households in the US spend $98 weekly on food when in fact they spend more. And a couple ways you can reduce that are to increase the alpha level or increase the sample size. And there's a couple other ways you can do that also, but those are just the two that I came up with. Moving on to question 10 on the last page, it says a researcher decides to perform a significance test of null hypothesis being that the mean is 100 versus the alternative hypothesis, mean being greater than 100. It says part A, for use the screenshot from the power applet below to determine the probability of making a type 1 error and the probability of making a type 2 error. So the probability of a type 1 error is just your alpha level, and I know it's basically impossible to read on the way I scan this, but it says right here that alpha is 0.05, so the probability of a type 1 error is 0.05. And the probability of a type 2 error is 1 minus, which is, type 2 error is beta, and the formula to get the beta is just 1 minus the power. And the power, which again is shown to you down here, and you can't read this number, I realize that, but it's 0.438. So you do 1 minus 0.438, which gives you 0.562 for the probability of a type 2 error. Part B, explain specifically what the applet shows about the power of the researcher's significance test. You're going to think this answer is not specific enough, but it's what the answer key had. So I just said the power of the test is 0.438, which is not very high, and it shows me that the results of the test are not necessarily very reliable. And that's pretty simple, but that's what all you need to say for this kind of thing. Part C says to explain how the researcher increased the power of the test in the screenshot below. So again, I can't really see what number the power is here, but assuming just visually, it looks like a larger percentage, so it's a higher it's a higher value. The way that they did this from here, you can probably see this on your paper, but you can't see it necessarily on my scan. The alpha level is now 0.10. And so we talked about this in question 9 on part C. One way you can increase the power is to increase the alpha level. So the alpha level in part A and B was 0.05, and now in part C it's 0.10. So they increased the power by increasing the significance level. And that's the whole practice test.